in lesson 3.6, we're going to be talking about basically 3 different things. So you have to kind of think of this as 3 different ways that you're going to solve stuff, but they all deal with absolute value. So first we're going to go over absolute value equations. You've done this before. Then we're going to go over absolute value inequalities. And there are 2 types of absolute value inequalities. They relate exactly to the 2 types that we talked about in lesson 3.5, the and the or inequalities. So you're going to end up with 3 things today that you need to be aware of by the end of the day. Already done this, need to learn this. So equations we're going to start with. Example 1 asks you to solve absolute value of x plus 5 equals 11. Here's the key to these. The key to these is you're trying to isolate the absolute value. Okay, so that's the first deal with these. So you isolate what's in the absolute value first. Okay? So that's going to be your first step. So look at this like an equation. Isolate the absolute value. Don't worry about the fact that there's only an x there. The way I'm going to isolate this absolute value is I'm going to subtract 5 from both sides. I end up with absolute value of something equals 6. Once you have the absolute value isolated, take the absolute value and drop the part around it that's showing absolute value. As you set up 2 equations. Okay, as you're going to set up 2 equations. And if you all remember, we've already reviewed absolute value this year. Absolute value, you can probably all already see the possible answers here. You know that this could be 6 because the absolute value of 6 is 6. You also know it can be -6 because the absolute value of -6 is 6. So what you're doing is you're taking whatever's in here and you're setting it to the positive version and then the negative version of the answer. So set up 2 equations, one with the original positive answer and then one with the opposite, which is going to be a negative answer. And then I'm going to put something here because it's going to tie into your next example. Solve for the variable in each equation to find 2 solutions. Typically, you're going to have 2 solutions for these. So go ahead and hit pause because I know I just wrote that really fast. Finish copying it down, and then once you're done, we'll continue going on here. And I'm going to go through this one more time also before. You need to isolate what's in the absolute value. Don't even worry about the fact of what's in there. Just isolate whatever is in it. Once you've done that, you drop your absolute value as you set up 2 equations. One of the equations is going to be whatever was in the absolute value equals the original positive answer. And then the other equation is going to be whatever was in the absolute value with the negative version of the answer. And then this is the added step in our next example. Now you solve for the variable in each equation to find your two solutions. You're almost always going to have two solutions to these. You'll come across a few and you'll see why you only have one every once in a while. And then there's also a time that you have no solutions. Think about right here. If this absolute value is equal to a -6, is that even possible? Are you ever going to be able to get to a -6 there? Hopefully most of you said no. There's no negative out here, so there can't be a negative there. This could never be negative. Right here, when I said 1 with the original positive answer, as soon as you have a negative answer here and this is alone with nothing on the outside of it, then you know that you have no solutions, and you can just write no solutions and move on. You wouldn't even have to solve. It's different if there's still stuff over here. It's only when this is completely isolated, the absolute value, and that's negative. So now we're going to go into setting up our two equations here. So I'm going to drop my absolute value, and I'm going to set up 1 with my positive answer, and I'm going to set up 1 with my negative answer. Now in this case, x is already isolated, so I'm done. Those are my answers. So the answer to that is 6 or -6. Let's try another one. Go ahead and write this down and try to solve for me. Try to isolate it. Hit pause, and when you're ready, hit play so that you can watch me go through it to make sure you've got the idea down. So you're going to isolate the absolute value, whatever's in here, same way you've been isolating anything in your equations. I need to move this before I can divide. So I'm going to add 2. I end up with 6 equals 3 times the absolute value of w. Now I still want to isolate it. This is multiplication. So I'm going to divide both sides by 3. 6 divided by 3 is 2. So 2 equals the absolute value of just a w there, which can also mean absolute value of w equals 2. Property of equality, those are the same. Now I set up two equations as I drop my absolute value. W equals my original positive answer. W can also equal the negative version of that answer. And I'm done. I don't have to solve anymore. So it's 2 or -2. Here's example 2. Notice the difference here. The absolute value is around this whole entire piece right here. So we have two terms in there. A lot different than this. Here's the number one mistake that's made in these. When you have the variable alone in absolute value, you're always going to have this, where it's the positive and negative version of the same number. In this case, you need to think about the fact that whatever's in here is going to multiply and add to be 11. Or it's going to multiply and add to be -11. That right there is not going to be the same number in a positive and a negative version. So these you have to be very careful, because you should not end up with 2 -2 or 4 -4. You should end up with two completely different numbers each time you solve. So you're going to follow the same rules. You're going to isolate the absolute value, which in this case, it's already isolated. I don't have anything to move to the other side. Now that I have an isolated absolute value, I'm going to follow the same rule. Set up two equations, one with the original positive answer, one with the negative version of that answer. So my first equation, 2p plus 5 equals 11, or 2p plus 5 equals -11. And now I'm going to solve each of them individually. So I subtract 5, 2p equals 6, divide by 2, p equals 3. Or, now I'm going to solve on this side, and I should not get -3 as an answer here. It's very rare that that would happen. Subtract 5 from both sides. 2p equals, be careful here, negative 16. Divide by 2, and p equals negative 8. So your two solutions here are 3 or negative 8. And here's how you check it. Plug in 3 for p. 2 times 3 is 6. 6 plus 5 is 11. The absolute value of 11 is 11. Now plug in negative 8. Never, if you accidentally came up with negative 3 here and you were spending the time to check that. Negative 3 times 2 is a negative 6. Negative 6 plus 5 is a negative 1. The absolute value of negative 1 does not equal 11. So if you're taking the time to plug your answers in and check, you should never make that mistake right there. Now I'm going to take negative 8 and I'm going to plug that in. Negative 8 times 2 is a negative 16. Negative 16 plus 5 is a negative 11. The absolute value of negative 11 is 11. And that's how that works. I want to show you an example of one where you might end up with what I talked to you about, where they might end up being the same answer, just so you can see that. Notice this is already isolated. You have nothing to move away from it. So you're just going to set up your two equations, 7d equals 14, or 7d equals negative 14. And then when you solve in this case, notice d equals 2, or d equals negative 2. So that is one of those rare ones where you actually will end up with the same thing twice there. 7 times 2 is 14. Absolute value of 14 is 14. 7 times negative 2, negative 14. Absolute value of negative 14 is 14. That's how you check those. Go ahead and write this one down and try it. Hit pause when you're ready. Correct it with me and hit play. So hopefully you set up two, it was already isolated, so you set up two equations, c minus 2 equals 6, or c minus 2 can equal negative 6. And then when you solve this one, you add 2, you get c equals 8, or add 2, and you get c equals negative 4. So your answer should have been 8 or negative 4. If you didn't get that, go look at what you did wrong so you can figure it out. Go ahead and try this one. 12 equals negative 4 times the absolute value of k. Make sure your absolute value symbols don't end up looking like ones. Right here, when you divided by negative 4, checking to see who was listening to me a little while ago, you have negative 3 equals absolute value of k. When you go to set this up into two equations, you have to stop here and realize the first equation should always have a positive answer here. You know that there's no way that you can have a negative over here with nothing on the outside left of that absolute value, so automatically it's no solution. Go ahead and copy this one down and try this one. Hit play when you're ready to look at it. So remember the rule, you have to isolate the absolute value first. Absolute value of x equals positive 7. Some of you might have accidentally, just from here with the negative 3, seen this right here and automatically said no solution, but you need to remember absolute value needs to be isolated first, because once we added 10, this answer actually became positive. Now from here you set up your 2, x equals 7, x equals negative 7. Now we're going to talk about the absolute value inequalities, and there are two different rules you're going to need to memorize. First one is that you're going to set up an OR compound inequality, which is our first part of lesson 3.5, if you ever have a greater than or equal to absolute value inequality. So if you have something that looks like this, absolute value greater than or equal to, or just a greater than, some number, then you're going to set up an OR compound inequality. And if you need to, go to lesson 3.5 part 1 for those. So let's go through the example. This is actually example 4 in the book. It asks you to solve and graph the absolute value of x minus 3 is greater than or equal to 4. Notice this is different than what you were solving at the beginning of the chapter because you have absolute value around something. So if this didn't have absolute value, then you would just add 3 and you'd solve for x. But because you have absolute value, this tells you need to set up a compound inequality. And because it's a greater than, you're going to set up an OR. Now this is going to take some memorization. So in order to set up the two inequalities, the first one is just going to be the regular inequality with no absolute value. X minus 3 is greater than or equal to 4. Or, this is your second one, and this is the one that's a little harder. You have to deal with this same idea of the equations. This whole thing could equal 4, but it could also be negative 4. When you bring a negative over here, this, you kind of have to think about that rule we talked about with our negatives coming across when we were multiplying and dividing. This is going to flip around with it. So the second one is going to be set up as x minus 3 is less than or equal to negative 4. So your first inequality is exactly what you had with no absolute value. Your second one, you changed this piece right here and that right there in order to set that up. Now you're at lesson 3.5 part 1. Solve each of them individually, and it should have that pattern of an OR graph. So here I'm going to add 3 to both sides. X is greater than or equal to 7, or x is less than or equal to negative 1. Probably should have gone a little further there. X is greater than or equal to 7. Closed dot goes up. And that makes sense. I check it and make sure. X is less than or equal to negative 1. Closed dot because it's or equal to. And it's all of the things that are less than. Checked it, makes sense. And it follows the pattern of the OR compound inequalities. This is all lesson 3.5 right here, part 1. The only new thing that you just learned right now is that when you see absolute value, you're going to follow the same rules as we did with the equations. I'll show you an example like that. But then you're going to set up 2 when it's a greater than. First one is the same. That's the part you have to memorize. Flip your inequality and make a negative. go ahead and write this down on the left. It's exactly what we talked about. So you're setting up two inequalities. First one is the same as the original, just with no absolute value. Second one, you drop that absolute value, make the answer side, if it had been an equation, negative, and flip your inequality around. And then at the end you could add solve and graph, if they ask you to graph it. Hit pause if you need to, hit play when you're ready to go on. Go ahead and try setting up your two equations for this one. And then solve and graph it, and then hit play to check it with me when you're ready. Remember to follow these steps right here. First one is just the original with no absolute value. W plus 2 is greater than 5. Notice here all of our absolute values are already alone. Same rule as in the equations. You would need to isolate that absolute value before you could set this up, if you ever came across one that was more difficult. Second one, W plus 2 stays the same. This flips around, this becomes negative 5. Now solve each of them. And that's what you should have come up with. When you go to graph it, you should have had an open dot at negative 7, everything that's less than negative 7, and an open dot at 3, everything that's greater than 3, and you check it and make sure that makes sense. The other type you're going to come across is an absolute value inequality that has a less than or equal to sign. These are the kind where you're going to set up an and compound inequality, which is less than 3, 5, part 2. So this is the kind where you write it as one long inequality, if you're writing it in proper form. So go ahead and write the example. I have it in here as example 5. It's actually still part of example 4 in your book, I think. Yeah, 3 and 4. And the example asks you to solve and graph. Absolute value of x minus 4 is less than or equal to 3. So when you see absolute value, you know you're setting up a compound inequality. Then you have to look at the inequality to see if it's going to be an and or an or. In this case, and, because it's a less than or equal to. So this one you set up a little bit different. I'm going to put and here so you think about that as you're setting it up. Here's what you do with this one, and you just have to memorize this. So this lesson takes some memorization. Drop your absolute value, take that whole piece, and leave space to the left. X minus 4 is less than or equal to 3. Now if you memorize it, it's not that hard. All you're going to do now is take this exact piece here, less than or equal to, put it there. Opposite of that, put it there. So you literally bring this down, and then on the left side you just write the same inequality, negative version of what was your answer here. Now you have a compound and inequality, and you just solve for x. You need to get x alone. Remember, this is lesson 3.5 part 2. So I add 4, add 4, add 4. Negative 3 plus 4 is 1, less than or equal to x, which is less than or equal to 7, and I'm done. And then when I go to graph it, I'm going to have a closed dot at 1 and a closed dot at 7. And remember, these and ones, x is greater than or equal to 1, so it's going up from 1. X is less than or equal to 7, so it's going down from 7. It's everything in the middle that gets shaded. I know I made that look really easy, but it can be confusing, so take a look at that again. Wrote the inequality the way it was, same inequality over here, opposite sign over there, and then you solve it like one of the and inequalities. Go ahead and write this down. Just hit pause, write it down, and then hit play when you're ready. That's what we just talked about. You're dropping the absolute value, writing the original inequality but leaving space to the left, and then to the left of it you're going to put that same inequality that the original had and the opposite or negative of the original answer side. So we're going to talk about this one because this can look a little confusing, but you just want to follow the exact same rule. It's just the easiest version of these. So you're still going to take, I see absolute value, I see a less than sign. So I know I'm setting up an and compound inequality. Take my original inequality, write it with no absolute value. Then all I'm going to add to the left is the same inequality, opposite of that. And since w is already isolated, that would be my answer. Negative 2 is less than w, which is less than 2. And when I go to graph it, I should have open dot at negative 2 and 2. The middle should be shaded. So we're not going to worry about solving it right now, but I just want you to try setting it up. If I gave you absolute value of p minus 4 is less than or equal to 8. So you noticed it was a less than. So you're just going to bring this down. P minus 4 is less than or equal to 8. Then you bring that same inequality over, opposite of 8. And that would be set up. If I had given you this, completely different setup. This was a less than, this is a greater than. So this one would be and, this one is or. This is the one where you set up 1 like it is, or 1 with the same here, switch your sign, opposite of the original answer. That's your difference on those. You're going to work on this tomorrow, and then we'll work on it more on Friday because I know it can be confusing. Make sure you use your notes to try to help you tomorrow.